Hi, thank you for watching this tutorial video on the visual circuit with the short takeoff and fixed nozzle slow landing in the AV-8B Harrier. So in this video I'm going to cover what this particular circuit is used for and some variations, and then I'm going to demonstrate the pre-takeoff data assignment, the one finger checks, the takeoff itself, the circuit, and finally the slow landing. Really simply, the short takeoff, slow landing visual circuit is primarily used for either practice or for assessments of some description. In this case, you're learning this to pass the VSTOL course assessment. So the big difference between this and, say, if you're doing it at a large airfield where the runway is quite long, let's say Anderson, you've got quite a long runway, is that after you do the capture attitude technique and do the acceleration, the transition to the accelerating transition to wing-borne flight, with the VSTOL assessment specifically, you leave the nozzles at 25 degrees. However, if you're operating from a larger airfield, you might bring the nozzles all the way to 0, as well as bringing the gear and flaps up as normal for the accelerating transition. And that's just because if you've got long runway, you don't want to be doing 180 knots the entire way because you go into conflict with other jets in the circuit, so you want to get up to 250 knots as quickly as possible. Okay, so let's get straight into the pre-takeoff data assignment. Before I do that, I'm just going to set up my cockpit the way I like it. So I'm just going to click myself up once or twice. Nice visibility over the front. Let's wash out the moving map a little bit by bringing the gain down, and then I'll just make it a better color for VR, and I'll bring the scale down. Okay, cool. And hit the zoom button and then bring the scale down. I did not hit the zoom button. Okay, so that's sorted. I'm happy with the way the cockpit's set up. Let's go straight into the pre-takeoff data assignment. So on the left MPCD, let's bring up the VRES page. Straight weight, let's replace the basic aircraft weight with the operating weight, which is 16,475. BDI we're going to replace with 16. And then straight away we're going to go into STO. We're going to overwrite the outside air temperature with 29 degrees Celsius. Field elevation, now because it's an assessment, I'm going to 0 the altimeter to get an accurate QFE, just because it makes my life easier. Again, as always, remember not to continue scrolling down after it reaches 0, otherwise when you take off the altimeter won't come alive straight away. It may come alive at a much higher altitude and give you a false reading. Okay, field elevation we are going to set to 0. FDAT runway distance, we'll set that up now. Runway distance is 4,100 feet. Runway heading is 246 degrees. And the ground wind is 338 at 9 knots. 338 at 9 knots. And that is that. Now, in the bottom of the VRS page, we're going to hit abort, get our abort speed. So in this case, we are going to do a dry takeoff. So that's going to be 103 knots. So if we get above 103 knots and we want to reject the takeoff for whatever reason, we either need to just eject, or we need to get the aircraft clear of the ground, get it pointed in a safe direction and eject, or potentially, if we've got the performance, do some sort of land ahead recovery if safe to do so, or a circuit recovery if we're able to do so. 9 times out of 10, if you need to abort the takeoff for whatever reason, you're above 100, whatever the abort speed is, you are going to need to eject. It's as simple as that. Okay, so our NRAS is going to be 74, so we'll do that now. So go into VSTOL master mode by hitting the VSTOL button here. I did it on my HOTAS. We put in the NRAS, which is going to be 74. Pitch carrots should be at 14. That's fine. No, the ground roll is going to be 550 feet, which is fine because we've got about 1,400 feet here. And our nozzle angle is going to be 60 degrees. We'll look front, there we go. So it's important to note this is the only time that you may find that the nozzle angle varies. Generally, it's always going to be consistent. If you're doing a maritime short takeoff, it's going to be 60. If you're doing a rolling vertical takeoff, it's going to be 70. And if you're doing a vertical takeoff, there's going to be no STO stop. However, if you then move into your one finger checks, which we will do now, you will find that your nozzle angle for the start of the takeoff is always the same, and in this case it's 10 degrees. Okay, so coming over the left, let's do the one finger checks. So we'll just make sure our lights are as desired. Coming forward, STO stop's already set, we've done that. Nozzles are at 10, we've set that. Coming forward, we're going to put the nose wheel steering into, sorry, the anti-skid in the on position. We're going to bring the flaps down into the stovel position. We're going to put the combat water on. We're going to leave the takeoff water off. We're going to set the left MPCD back to the EHSD, the right MPCD back to the hood, and we are good to go. So perform the takeoff, really simple. I'm going to do a standard short takeoff. I'm going to use the capture attitude technique. When the nozzles get to 25 degrees, I'm going to leave them there and I'm going to do my touch check. So clear the STO stop and check the waters off. If you were doing, say, a circuit at Anderson, as I've said before, when you reach 25 degrees nozzles, you would bring the power back a little bit so you don't run away with yourself or burn the engine out. You would then bring the flaps to the auto position, then the gear up. Then you'd program the nozzles fully to 0, and then you do your touch checks. But because it's a short runway, we're going to stay at 25 degrees nozzles, and that's what you'll be expected to do for your assessment. One last thing I forgot to do is set up the course line. We're going to need that. 338. No, it's not 338, it's 246. My bad. Okay, once we've done that, we're going to climb out to 1,000 feet. We're going to level out. We're going to trim for between 10 and 12 units of airway, straight and level. We're then going to start the left-hand turn onto the downwind. When we roll out on the downwind, we're going to aim to have our track reciprocal to the course line. So we're going to have to reference the AHSD for that. So looking outside and inside, good lookout attitude instruments work cycle. And we're going to look to be between 0.8 and 1.0 nautical miles on the delta distance. Once we reach approximately the midfield point, so being the center of the runway, we're going to bring the nozzles back to 60 degrees, and we're going to push the nose down to account for the balloon. We're then going to allow the nose to come back up, and we're going to readjust the power again to establish 10 to 12 units of airway, straight and level flight in the new configuration. Once we reach the beam, the DLA, which in this case is exactly where we're sat right now, so it'll be somewhere over there, we're going to time for 10 seconds, and then we're going to start our turn. And during the gates, we're going to look to be between 500 and 600 feet on the 90, so that's halfway through the turn, and then rolling out onto the key at 325 feet at 0.6 miles. And then it's just going to be less than a 500 feet per minute rate of descent, maintaining 10 to 12 units of airway with the stick, maintaining your rate of descent with the throttle, and then putting the witch's hat on the horizon at the touchdown, kick off the drift to get rid of the crosswind and opposite aileron to keep the wings level, put it on the scent line, track scent line, and perform positive nozzle braking. So let's demonstrate that now. So holding the brakes, let's advance the power. Need to take the parking brake off first, rookie error. So let's advance the power. Holding the nose wheel steering button. Release the brakes on the skids. 45, let's release nose wheel steering button. There's the NRAS, STO stop. Nozzles forward, 225, capture attitude technique. Bring the power back a little bit. Touch checks, STO stop clear, water's off. And just glancing down at the EHSD to make sure we are tracking runway scent line. Bringing the power back a little bit, we don't want the jet to run away from us. Putting the witch's hat and the velocity vector together in the climb helps a little bit. Coming up on 1,000 feet above the landing area, and just dropping the nose and adjusting the power and trimming for 10 to 12 units of airway. Okay, that's all good. Let's start our turn. So a good lookout. And let's start our turn. adding a bit of power in the turn and using a little bit of rudder to help me get the nose around. Just a little bit of rudder, as you can see there on the indicator. And I'm just going to bring the scale out a little bit so that I can see my course line. 0.4s, we're halfway through the turn, maintaining that lookout attitude instruments work cycle. So look out the cockpit, reference attitude on the hood, use the instruments to confirm accuracy. So we're at 1.0 miles. 1.2, so we're just about got a little bit wide. We want to be between 1.0 and 1.2 nautical miles. Okay, so we're a little bit wide because of that crosswind. So we're just going to point in a little bit to correct for that. And check the downgoing wing. Everything is fine. Bring the scale back down. And we're at 1.4, 1.3. .2, there we go. Good stuff. Bring the nose back out. And let's bring the nozzles back to 60. Back to 60. Notice the balloon counteract by bringing the nose down. Track is reciprocal. And then adjust the power and the trim to maintain 10 to 12 units straight and level. .10 seconds up to 45. And we're at 4.5, so let's descend on turn, looking for between 10 and 12 units of airway in the turn. And we're looking to be at about 600 feet once we're halfway through this turn. Okay. Need to increase this rate of descent drastically. Airway is a little bit low. Might find that you square the turn off a little bit, that's absolutely fine. Always better to make the first half of the turn a little bit sharper than it needs to be so that you can be in the required position to make a good final turn. Okay, this is looking good. We're at 600 feet, so we're still within that limit, but a little bit higher than I'd like to be. Bringing it down to 500, putting in a little bit of left rudder. That's 480. And we're on the 45 now at 420, so that's good. Altitude. We're at 0.7. Altitude. There's 0.6 and we're at 320. Nicely done. Just allow the aircraft to come down, 10 to 12 units of airway. Which is hot on the horizon, adjust the power, maintain the airway, no more than 500 feet per minute, kick off the drift, opposite aileron, close the throttle, bring the nozzle back positive, nozzle braking, use the rudder to keep it centralized, no more than 70% RPM during the braking, wait until we're less than 50 knots, close the throttle, reset the nozzles, and apply the toe brakes. Keep the aircraft going centralized until we're at a reasonable speed, center the rudder, and then use nose wheel steering. Caution. And engage the nose wheel steering in the anti-skid position. And we can clear the runway. Okay, so main things to note. Delta distance between 1 and 1.2, so it's a little bit wider than the other maneuvers, which are obviously 0.8 to 1.0 on the delta distance. Secondly, when you're performing that turn, you might find that you choose to make the first half of the turn a little bit tighter. That's fine. It's more important to make sure that your first half of your turn's tighter than have to overbank on the second half of the finals turn. Again, opening and closing crosswinds. In this case, the opening crosswind on the turn after the climb out pushed me wide, and then the closing crosswind on the final turn made it a little bit difficult to judge when was the right time to turn, how tightly to turn. I like to use just outside of this canopy bow, so about a hand's width to the left of the canopy bow. That's where I keep the runway. And then, of course, remember where the crosswind's coming from, because as you come in to touchdown, you might find that the wind's actually blowing you right to left, or left to right in this case. The wind was blown right to left. So I've rolled out with my nose pointing a little bit right of the runway, which might feel a little bit contradictory at first. You may also find that in order to meet your airway and your checkpoint altitudes, your gates, you might find that the nose seems to be pretty aggressively down. That's normal. The important thing is that obviously once you're in close, you need to check the witch's hat on the horizon and adjust the power to maintain a given rate of descent, and just ignore the airway from that point onward, because you're now relying predominantly on the engine. Obviously, it's a little bit different with a slow landing. Especially in high crosswinds, really important to do proper positive nozzle braking. Do not use nose wheel steering in any way, just use the rudder. Once you're slow enough, engage the nose wheel steering using only the nose wheel steering button after you've centralized the rudders. Once you feel that the aircraft's under control, then move the anti-skid switch back to the nose wheel steering position. Remember that if you bring the nose wheel steering on whilst you still have the rudder deflected, say the wind is to your right and you're pushing rudder right to counteract. You might find that you're pushing the rudder left to counteract the wind, because the wind is actually pushing the rudder at the back on the right hand side, so moving the nose right. And then as soon as you press the nose wheel steering button, you find that left input is quite drastic, and it bounces you off in the other direction. So just remember to get it under control before you activate the nose wheel steering. I hope that you found this video useful. If you have any questions, please feel free to contact me. Thank you very much.